Okay? Remember, this picks up everything, and it's going to be for the whole world to listen to giggling girls in my class, okay? All right? Okay? All right, so what we're going to look at is we're going to look at the sum and difference formulas for cosine and sine tonight, and I'll finish up with that. Okay, so you have to memorize these two identities, and I'll show you how to use these. These are called the sum difference formulas. I'm not going to do a proof of these because the proof of these formulas is pretty complicated. Sometimes I give students an application problem where I kind of walk you through the proof, but it takes a lot of work to prove that. So anyway, what this is saying, like, if you had a cosine of, say, something like 45 degrees plus 30 degrees, which is really 75 degrees, well, you could use that identity and you could get the exact answer, okay? So the first thing is you got to kind of look at the structure of this. When you're doing the cosine of two angles added, you just do the cosine of the first, cosine of second, then you do the sine of the first, sine of the second, and then the sign is different. If it's a difference identity where that's a difference, then it goes cosine and then cosine, different sign and sign like that. Now I have a little stupid rap that I do. It's not a rap, I don't even know what it is. It's just, this is for whatever reason sticks in my head. When I see a cosine sum identity, I just think cosine, cosine, sine, different sign. Isn't that stupid? But it sticks in my brain. This goes cosine, cosine, sine, different sign. Like that. So it's got a simple structure. Two cosines, two sines, different sign. So when I'm teaching that, I'm always thinking that. And for years, that's how I've remembered that formula. Cosine, cosine, sine, different sign. Okay, so what I'm going to do with this one is in radians. So the first thing I'm going to do is, to me, it's just as easy if you're in radians to change it to degrees. That's the way I'm going to teach it. So if I replaced pi with 180, and then if I did 180 over 12, I'm pretty sure that's 15. And then if I do 5 times 15, I get 75 degrees, okay? So what we're going to be working with is we're really doing the problem sine of 75 degrees. Okay, not sine, cosine of 75 degrees. Okay, so what we're going to do is we're going to apply that identity, and it's going to be on a unit circle. So we go like this. The identity, if you remember what I'm trying to show you, you could break that up into 45 plus 30. Now, why am I doing 45 plus 30? Why not 70 plus 5? Because 45 and 30 are special, right? They fall on the unit circle. So the problems I give you are going to have some combination that comes out of those special angles on the unit circle. So what we do now is we do the identity. So we do the cosine of 45 times the cosine of 30, leave a little space, then do the sine of 45, and then do the sine of 30 like that. And then you have the plus, remember it's different sign. Cosine, cosine, sine, different sign. Okay, like that. Now all of this stuff comes on the unit circle now. So the cosine of 45 is the x value, so that's square root of 2 over 2. The cosine of 30 is the x value, so that's square root of 3 over 2. So this is going to become square root of 2 over 2 times square root of 3 over 2, like that. Then they got the minus sign. Now we do the sine. Well, the sine is the y value, right? So we just get that information from our unit circle. The sine of 45 is square root of 2 over 2. The sine of 30 is 1/2. Everybody okay with that? Okay, that's just basic unit circle stuff. That's what makes this a little easier for students, is because it's now kind of getting back to repetition and things we've been doing for a while. So you can multiply that out and you would get square root of 6 over 4. If you have two numbers under a square root, you can put them together in one square root. And then over here, that would just be square root of 2 over 4. And then you want to just put it together in one fraction. Okay, there's actually two ways that you can write this. I usually prefer that you just write it like that as the final answer to the problem. And then sometimes my math lab and other textbooks write it as 1/4 times root 6 minus root 2. You can also write it that way. It's the same thing, right? So that's how that would go. All right, so that problem's usually very simple for students to learn. What do you guys think? Is that pretty straightforward? Okay. The other thing is, see, that's an exact answer. So 75 is a new angle that kind of becomes special, where we can get the exact value of the cosine on. Another thing you can do on this, which I'm going to go ahead and do just one time to remind you that all this stuff is verifiable on a calculator. So I'm going to do this. You don't need to do this, but you can if you want to. So in degree mode, if I do the cosine of 75 degrees, I'm going to get a bunch of decimals. It's an irrational number. But then if I do this thing right here, and I've already done it right there, if you do square root of 6 minus square root of 2 over 4, you get the same thing. So what I'm suggesting is you can check your answer just by doing the cosine of 75 and doing your answer and seeing if they're the same. Everybody see that okay? All right, so it's verifiable on a calculator. Okay, so let's do another one like that. Just kind of get ourselves comfortable with this. So we're going to work with the cosine of 345 degrees. So the first thing that you want to do is you want to look at your unit circle and you want to look at all these angles and just figure out how to put a combination together that's going to give you 345. And there's all kinds of combinations. Do you guys see anything? Use the special angles. What's that? 345. Ah, that's exactly what I was thinking. 300 degrees plus 45 degrees. Okay, now if you want to do it another way, I don't care, as long as it's right. You'll always get the same answer as long as your combination's good. But try to keep it simple, so good. So let's do this as 300 degrees plus 45 degrees. As long as you have two good angles on the unit circle, then you're good. Okay, then we write our identity. So the identity is easy to remember. You do the cosine of the first, cosine of the second, then you do the sine of 300, sine of 45, and then it's the opposite sign. So it's the cosine, cosine, sine, sine, different sign, okay, like that. All right, now we go to the unit circle and we just get everything kind of put together. So if we're looking at 300 degrees, the cosine of 300 degrees is going to be the x value, so that's a half. Okay, do you have cosine of 45 memorized by now? Usually students do, square root of 2 over 2, okay? So that takes care of that. Sine of 300 is going to be that, and it's going to have a negative in it, so be sure that you put that negative in there. So you have negative square root of 3 over 2 like that. And then the sine of 45, hopefully you have that memorized by now. That's square root of 2 over 2, because you're sure that shows up all the time. Okay, now we just clean it up and see what we get. So if we multiply this first fraction out, that's just going to give square root of 2 over 4, like that. Now be careful here, you got two minuses, so that's going to turn into a plus now. That's positive. So that's plus square root of 6 over 4 like that. Okay, so now what we're going to have is, when we put this in the same fraction, we're going to have square root of 2 plus square root of 6 all over 4. It doesn't matter what order you put the numerator in, and that's the right answer. Okay, now one thing I want to kind of, that it's to me is pretty important to think about on these problems is at least think about this. The cosine, what is the cosine of a quadrant 4 angle? Positive or negative? Positive. Remember, cosine's x over r. X is positive that way. Is my answer positive just by looking at it? Yeah. Okay, so you're going to, little things like that are good things to see. Okay, what do you guys think? You guys following along okay? Students usually thrive on this and don't have hardly any trouble at all. That's a good thing. Okay, so let's finish up here tonight just with this, just this problem right here, and then I'll let you go. This one right here is, what you see with this one is 165, that's not a special angle. But what I see on this is, what I'm hoping you see, is the identity in reverse. What do you have? Cosine, cosine, sine, sine, right? So we could put that together in the identity backwards. That's the purpose of that problem, is to show you how to put the identity backwards. So it's going to go like this. What we're going to have is we're going to have a cosine, and then we're going to have 165, and then we're going to have 45. Now the question becomes, which do we do? Do we add it or do we subtract it? What do you think? Subtract. How come? Because it's a different sign. Okay, so all I'm doing is I'm doing this in reverse. right? Everybody got that okay? Well, now just go ahead and work it out. I think that's 120 degrees. Okay, so if we want to find the cosine of 120 degrees, all we need to do now is just look at our unit circle and we're done. Okay, so that's kind of slick the way that works out. So 120, here's 120, cosine, the answer is -1/2. Okay, that's it. So you can sometimes do this identity in reverse, and when you do that, it simplifies things. That's the only way you can do that too. Cosine of 165 is not one of the special angles, so put it together that way. Okay, does that make sense? Okay? All right, so one thing I wanted to mention before I let you go here,